So we have a very different and interesting presentation now for 30 minutes. We have Dr. Anastasia Globa, who is a researcher, academic, and designer working in the field of architecture with strong research interest in algorithmic design, interactive systems, and simulations. Dr. Globa is currently holding a position of lecturer in computational design and advanced manufacturing, University of Sydney. She is a member of the COCOA Research Lab and Sydney Nano Research Center, closely collaborating with the computer-aided architectural design in the Asia community, being elected CAAD-RIA president in 2022. We have recently visited Sydney Nano. It's a wonderful facility we have seen, so glad to know that you're a part of that. The research work and most of the teaching done in the span of last 15 years in Russia, Germany, New Zealand, and Australia focuses on the use of computation, algorithmic form making, and integration of parametric modeling and architectural design. So some non-parametric and semi-parametrics would also be there, right? Her design and research and project often involve the use of various digital fabrication technologies, including the adaptation and prefabrication preparations of digital models for 3D printing, CNC routing, and laser cutting. Since 2015, Dr. Globa has further extended her skill set and developed multiple purpose using interactive virtual and augmented environments. VR and AR was applied in the projects involving the design, exploration, data visualization, and pre-occupancy simulations. She has extensive experience working in advanced computational analysis, simulation, data visualization, real-time interactive applications, and immersive analytics using both modeling and computer environments and gaming engines, such as Grasshopper, Reno, Unity 3D, etc. Dr. Globa specializes on the development and testing of digital and physical prototypes, interdisciplinary design, and academic industry collaborations. So the stage is yours. So you may present for around 20 minutes, and followed by we have 10 minutes of Q&A before we wrap up the session.
Thank you, Sandra. I think I have a mic. Thank you very much. I know that most of the people are still having their lunch, which is unfortunate for me, but thank you those who did come in and come. I really appreciate it. So just a little background on the projects, two projects that I'll be presenting. This is a little bit of outside of the usual scope that you've been seeing so far. My expertise in architecture, and so I'll be presenting research, the first research on the living materials. So we're looking into sustainability angle and how to make materials out of waste using mushrooms. It's quite an exciting topic. And the second topic would be covering the use of technologies such as computation analysis, performance simulation, and virtual reality to make a more sustainable and more effective architectural solutions. Because architecture is a huge contributor to the carbon emissions. That new buildings that are being built contributed massively. The concrete, all the new stuff. We're actually getting much better at cutting the operational things, but building new things is very, very inefficient still. So that's why making efficient solutions to begin with is important. So let's first look into the living materials for sustainable future, Myco-Materials. We all know that there's a huge problem currently with the massive amounts of waste that's being generated every day. And not only that, we're getting resources from one place, then we're moving it into the other. So all this transportation is greatly contributing to all this unsustainable practices that we're undertaking. So it is clear from all the presentations during the symposium, we need a circular economy. So better that we generate and use locally instead of shipping things all around the globe. And that's one of the UN Sustainable Goals, is to increase resource efficiency. So that was the main driver behind this project. So the opportunity. We're looking into mushrooms to try colonize the waste that we're producing every day. So this research is looking into how we can use mushrooms or mycelium. Actually, because you're not really biologist mainly, I'll just explain a little bit. So mushrooms, when you eat, is actually the fruit of the mushroom. There's also roots. The roots are called mycelium, and these roots can eat or colonize most of the biological matter. They can eat, and they do eat, wood, paper, but they can also as easily like to eat fruit, peels, or grass, or old rice, or used coffee, almost anything that we produce daily and throw away and produce waste. So mushrooms would like to eat it, and they degrade and colonize it. And if you don't let it root, if you cut off the sunlight, all the energy goes into the roots, and roots create this really firm material close to qualities of polystyrene that we could use in that we could use in yes in architecture. It's kind of weird to hear me repeat it. So this is the circular economy loop that we are kind of proposing or creating. So first, you're taking the waste and you blend it, you sterilize it a little bit, and then you inoculate it with the mushrooms. So you kind of bring mushrooms in, you put it into the molds, which could be big ones, yeah, or it could be like bricks, or it could be some insulation or anything. Really, I'll show you some of the examples. Then you let this mycelium grow. It grows pretty quickly. I just grew it at home. I started mushroom research because I couldn't interact with people during COVID. So that's how mushrooms came to be. Then you let it grow for 2 weeks, and it forms really firm matter that you can then dry, demold, and then use. These are the materials that I tested so far for producing these mycelium bricks or objects. The coffee one, I drink a lot of coffee, maybe not as popular in India, but I did manage to grow 95% coffee bricks, and they perform really well. So I also use popcorn from the movies, avocado peels, and all sorts of stuff that is quite typical in the context of Australia. You perhaps, but we did use, for example, foliage, rice, and some banana peels and fruit peels, so that could be quite relevant in the context of India as well. These were the examples. So these are the bricks that we grew, and we actually use takeaway containers as the molds. So you just use them, pack them with this waste, inoculate with mushrooms, and here we go. You grow these materials. They're excellent in dampening the sound. So if you need some good insulation or soundproofing, these are excellent properties for this. So this is a booming new research, how you can use living materials to take waste and produce something useful locally without any sophisticated equipment whatsoever. You can do it at home, and I actually would encourage you guys to try and use it. So I also looked into the aesthetics, because architecture, we really love to see this is pretty, because if it's not pretty, nobody gonna use it. We're like that humans. So you could use some of the foliage, so the finishes on the walls or materials can be the part of the aesthetics. So you could grow really leather-like elements. This is the mushroom, which is called Australian reishi. And this mushroom is the most resilient mushroom I came across so far. So there's lots of types of mushrooms, oysters, lion mace, these exotic mushrooms. Reishi would eat mold, so they compete the mold against mushroom when it starts to decompose, and reishi always wins as the champion of all the mushrooms. So if you guys want to try, do your own experiments, I would recommend going with reishi. And if you don't have it, I'll just ship it to you from Australia. So you could use any mold and shapes. It can take any shape. It's quite precise. It's interesting, sometimes it would, if the substrate is not small enough, it would not go into some parts of the molds, but then the mycelium roots will start growing and kind of colonizing it. That's where this beautiful white color comes from. That's the actual roots of the mushroom. So this is an exciting project where we prove that you can grow forms and architectural materials out of waste, out of almost any type of waste available. The mushrooms didn't like mandarins so much, but they loved rice. They have their own tastes, apparently. What we want to do next, we are looking into the hygrothermal properties. So the problem with mushrooms, they want to survive. So when you dry it, it'll be dormant. So it's called in the state of inertia. But once you rehydrate it, it'll try to fruit again, which is a big problem. We don't want the buildings to start growing mushrooms. So the challenge here, and that may be a challenge that I pose to you guys, how we can coat it with some hydrophobic, perhaps, coatings that will protect it from water and maybe also add more durability to the sample. So something to look into. Also, the material itself is really, really light, because all the energy from the colonized mushroom goes into digestive. When you dry it, it loses almost 80% of the mass. It's very light and very durable material. So hopefully I got you excited, about the mushrooms, and there will be maybe some time where you can ask your questions. So next project. Next project is completely different. That's my actual the interest that I started before COVID, before my mushroom adventures. This is to do with pre-occupancy evaluation in virtual reality, and again, just repeating why we're doing this. So the problem with architecture, that architects have these ideas, and then we build things, and then we think they would work well, and then people hate it, and it doesn't work at all, and it's too late to change it because it's already built. There is this thing in architecture which we call post-occupancy. So when we ask people, well, how do you like the space? Do you like the view from the window? Do you like this color of the walls? Do you like the temperatures? And yeah, this is post-occupancy. What we want to do is shift from post-occupancy to pre-occupancy. So allow people to occupy spaces before they actually build using virtual reality. And we already done that. I'll show you some of the examples. So this is making the change when it matters, before the building is built, using future occupants to inform decision-making in architecture. So this is the opportunity. We run the studies for these pre-occupancy evaluations with lots of test groups. These were the examples from Geelong when I was working at Deakin. Shout out to Vicky. So yeah, it's a small world. This is the evaluation loop. So to make efficient designs, you have to first calculate the performance. So this is the quantitative things we're looking into. For example, if we're looking into facades, we're looking how much light coming in. Will it gonna get overheated? Will it gonna get too much glare? What are the views out of the windows? And then this was the project for our law building in the University of Sydney. The facade louvers were originally designed to be kinetic. So they would rotate, and then people could choose they want them open or closed. Great idea in theory. In principle, it's good, but in reality, they all broke after about 1 or 2 years, and some offices had completely shut down the blinds for for a long time. So they decided to redesign it and make them static, to calculate the best closure open angle for best performance, so that you don't have to spend too much energy to cool the building and allow natural light in. They calculated it, and they had this optimal performance in numbers But then they wondered, what if people didn't want their shutters to be closed at almost 80%? They would hate it. They would be unhappy occupying the spaces. And that's why we implemented virtual reality simulations. We allowed people to actually move the blinds and see what it would mean in terms of performance in real life. We not only made it static, but we also allowed people to change the orientation of the view, change the sun simulation, so how it would look during the day, how it would look during the night, and also have some weather simulation. How would this space look when it rains, pouring rain, or how would it feel when it's sunny and happy? There's just a quick overview how you can model things in architecture. So sometimes when we do these sort of projects, we just model everything by hand, 3D modeling. But now we have a technology where you can scan things, 3D scan, and they can put directly into VR. So this is the, maybe let's kill the sound. This is the example of the implementation of VR loop for the building. We can still run it. So yeah, the people were able to change the rotation of the lever and see all the metrics, quantitative metrics there, change the weather. We run this experiment with the bosses, with the architects, with all the stakeholders involved, and they all had their opinions about the best, most effective solution. And this solution was actually not what the firm originally calculated. So these experiences, these subjective opinions of people, they mattered that much that they changed the design from what the numbers said to what people said, and kind of negotiated this. So instead of then after 5 years rebuilding it, now they had their pre-occupancy data, so they can make more efficient solutions early on. Yes, this is some of the tests that we run with the inside of the law building with the VR headsets. And that's it for today. So I just want to finish up with I know that's maybe a little bit outside of what you guys do, but I hope that there might be some potential crossovers, because the simulation technology, virtual reality technology, and also living materials are exciting topics. And I believe that if we do cross-collaborate, cross-pollinate between different disciplines, that's where the value can come from. There could be some unexpected takes or some creative applications for different spheres. So I would invite everybody to come visit us. We're welcoming PhD students or maybe exchange academics in our lab. And yeah, happy to collaborate. Thank you very much.
Thank you very much, Dr. Globa. It was an exciting presentation. I mean, we have been listening from last 1.5 days about various issues, and this is one of the interesting issues on living materials. We also have a lot of problems, at least on campus, the grooming mushrooms, and probably some of us can think about it and how to solve the problem. So this is a best example of how sustainable consumption and production can go in a circular economy, right? And there may be other living materials which people like you can try. Just before I open the floor, on the virtual reality, can you also try for the extreme climate events? That would be something which will probably change the way we construct, design the houses, or maybe evacuate people when they are not ready to evacuate, because generally people don't want to evacuate during the floods and the cyclones. So if that can be done, then it may become environmental education in reality. So that may be definitely a good way to think in terms of making people aware about the extreme climate events.
Thank you for the questions. This is an excellent example of what I probably should have presented, but yes, we do simulate disaster scenarios as well in VR using gaming engines and particle systems to simulate the propagation of fire, leveraging from those technologies. We just got Kickstarter from Sydney Nano to actually implement the meta city simulations where you try to simulate floods or fire and let people experience that changing parameters. What if they build their gazebo in here? Would the fire then grab onto that gazebo and then kill the whole house? Or, if they don't do that, then maybe their house will be safe. And when you just look at the picture or numbers, it might not be as convincing, but when you actually experience and in a playful way, that's much more effective.
Yeah. In fact, on a very lighter note, it will be a very good way for the insurance companies to use it as a tool to educate people how insurance can be covered for certain extreme climate events. Yes. So questions, please.
Thanks for the presentation. For the VR, have you or your team developed the code themselves, or?
Yes, we do. We have the team that looks into the user interactions, then the teams that looks into how beautiful it looks, and the team that does the coding. We also now started the direction with the machine learning, so using these predictions and scenarios running live based on the people's behaviors.
Oh, great! And are these people from architecture background or from computing or?
I'm sort of officially I'm in an architecture, but I work a lot with design.
The design.
Yes.
Okay.
With design people who do programming. So again, multidisciplinary. It's
Yeah,
no
yeah.
longer one discipline. It just branches out into lots.
Yeah, and I think this is how it should be. Shouldn't it?
Yeah,
Excellent. Thank you very much.
I have a question about the fungi. An engaging talk and out of the box thinking. So, two questions. Apart from the abiotic factors, how will you control for the biotic factors? Because you're essentially creating a biological ecosystem by building with fungi. The second question is, how durable are these materials?
So for the safety, this is actually edible mushrooms. So, well, in the worst case scenario, you could actually attempt to eat it, so it's really safe. And in terms of the, what was the second question? Durability. We are running tests. As I said, the properties currently close to styrofoam, but it really depends on what waste it is. If it's a popcorn, you can squish it easier. If it's coffee, you'd struggle. Coffee is really dense, so the density and the qualities of the output materials would greatly be influenced by what you give the mushroom to eat. But yeah, we're testing fireproofing, we're testing acoustics, we're testing how prone they would be to maybe moisture. All those sorts of things are being currently tested.
Okay. Thanks, Anastasia, for your very interesting presentation. And again, I have to say this is a bit of a friendly fire because we work together. I'm asking about the mushroom because there was this incident in Australia, particularly on the 29th of July, where someone invited some people just for a friendly meal in their home, and then unfortunately it led to the terrible poisoning, and all it was edible as well. So the real problem we have is, have you thought about taking tests on human toxicity potentials for these mushrooms over an extended period so that we don't inevitably poison people through this conference?
Excellent question, Buki. Yes, for your context, in Australia, there were one lady collected mushrooms in the woods allegedly and poisoned everybody she didn't like. I think there is a story in India about that as well. Certain Buddhists ate the mushrooms even though they knew they were poisoned. In replying to your question, don't lick the walls. Just as a general rule of thumb. But if you do, yeah, look at these pegs. Maybe we can make the walls make you happy also. There could be these parts of it as well. In theory, you could make it dual functionality. So it is a wall or it is some. People build lots of things out of mushrooms. Now they actually even doing applications such as coffin, because it's biodegradable, and instead of killing trees, you're taking materials that would be absorbed into nature and just sort of really disappear and grow. Yes, they become it's different way of thinking about materials. So no longer you take nature, you destroy it for yourself, you actually grow something with nature, together with nature.
Oh, Adam. Yeah. Nice presentation. I think looking at these bricks, and then you told that they are very much porous. It seems to me, in my imagination, it's a bioerosion kind of stuff. I don't know whether what is the surface area. I don't know, and whether we can call it a bioerosion. And the other thing is that what will happen in the extreme climatic condition. I think Professor Sau also probably indicated that question. So their survival and
Again, because it's quite such a new area, we actually welcome research. So perhaps you could undertake that. We're looking also at nanoscale, what's happening on the nanoscale, because mushrooms, they happening, the growth is they're tiny, and they're also quite finicky. We had samples, 10 samples, exactly the same waste, exactly the same conditions, but there is autonomy of the material because it's a living material. Some of them are more powerful and would grow more. Some of them are shy and sort of slower. Some would be brown, some would be white. So exactly the same. So this question of the material working with you, not for you, is also quite poetic as well.
Okay, so thank you very much.